So hello, good morning. So today we want to look at this question, and the question says, if y is equals to 3 cos cube 4x squared ln cos squared 3x squared, find the y dx. Okay, so this question, it has two functions, major functions in it. This function and this function. And these two functions, they are multiplying each other, which means we have to apply product rule to solve the problem, right? But also, each of these function is a function of function, right? So which means we need to differentiate it using chain rule, right? Okay, so we say let's u equals to 3 cos cube 4x squared. This one can be written as raised to power 3, right? It's like this. Okay, and v equals to ln of cos squared 3x squared, right? So this one can also be written like this, right? Okay. So now to differentiate this, we have to differentiate three things here. We differentiate the subject first, then we differentiate cos of that subject, then we now differentiate the power. Those are the three things we are going to differentiate. So that will be du dx is going to be differentiating the subject, that will be 8x. Differentiating the cos of that subject, that will be minus sine 4x, 4x squared. Now differentiating the power, so that will be 3 times 3, that will be 9, then cos 4x squared raised to power 2, right? So those are the three things we'll do there. Then we'll multiply everything out, okay? So that will be 9 times 8 times minus 1, that's minus 72x, then sine 4x squared, then cos squared 4x squared. So the square will be there as well. Now the vdx. Now to differentiate this, first is that this is a function of function as well. So we differentiate the subject first, we now differentiate cos of that subject, we now differentiate the power, then we also differentiate ln of the entire bracket and power, right? Okay, so first is that we differentiate this, so that will be what? 6x, right? Now cos of that subject, that will be minus sine 3x squared. Then differentiate the power, so that will be 2 cos 3x squared, okay, right? Then we now differentiate ln of everything. The ln, that will be 1 all over cos 3x squared, everything squared, right? Okay, if we multiply everything out, we are going to have 6 times 2 times minus 1, of minus 12x, then sine 3x squared, then cos 3x squared over cos squared 3x squared. This cos and this cos can cut each other, so that this is going to be minus 12x, then sine 3x squared over cos 3x squared that is left. That will be tan 3x squared. Okay, so that's that. So having done that, we now find the y dx, which is u the v dx plus v the u dx. Okay, so what is u? U is this. So that will be what? 3 cos cube 4x squared. The v dx, this is the v dx. So that will be minus 12x tan 3x squared. Okay, now plus v. What is v? V is this, ln of cos 3x squared, everything squared. Then the u dx, is this, minus 72x sine 4x squared cos squared 4x squared. Okay, that's that. So this is our dy dx. So let's simplify this. If you look at this, there are two terms here. Some things are common. Okay. Before we go that, let's multiply this together. This is 3 times minus 12. That's minus 36x cos cube 4x squared tan 3x squared. Then this one minus 72x sine 4x squared cos squared 4x squared. Then ln cos squared 3x squared. Right? Okay. So minus 36 and x common. Then this is cos cube 4x squared. This is cos squared 4x squared. That's also common. Cos squared 4x squared is common. So if we open the brackets, so what is left here is cos 4x squared, then tan 3x squared plus 2. That is 36 and 72. That's 2. Then we still have sine 4x squared. Right? We still have sine 4x squared here. Then ln cos squared 3x squared. Okay? So this is the factorization of that entire expression here. So this is now our dy dx. Okay? So these are dy dx. Okay? And that's the solution. Thank you. Please like, subscribe, share. Okay?